Hello, welcome to the Tile Roofing Industry Alliance presentation of high wind examples in the 160 mile per hour wind zone. We'll be looking at the new rules of ASCE 7-16 along with the 6th edition of the Florida High Wind Installation Manual. I'm Paul Lexak, Technical Trainer, Boral Roofing, and I'll be going through 6 examples of roofs in the 160 mile per hour wind zone. Here's the map, which is on page 32 of the FRSA TRI 6th edition, showing the 160 mile an hour wind zone according to the new ASCE 7-16 wind map. You'll notice Miami-Dade and Broward are in that zone, but do not fall under the FRSA TRI 6th edition code. For those areas, use the NOA. The big difference between the old manual and the new 6th edition FRSA TRI High Wind Manual is different types of roofs or roof style. The old manual had one style roof. The new manual separates the tables into hip roofs and gable roofs. Also, another difference with the ASCE 7-16 are the individual roof zones located on a hip and gable roof. In ASCE 7-10, there were 3 zones for all roofs. In the ASCE 7-16, the new 6th edition of the manual, there are 6 different zones for gable roofs and 4 different zones for hip roofs. Let's look at the roof zones for ASCE 7-16. In Figure 1, hip roof, you'll see 4 different zones. Zone 1, Zone 2E, Zone 2R, and Zone 3. In Figure 2, gable roofs, you'll see 6 distinct zones. In the manual, they have divided these zones into either a low pressure zone or a high pressure zone. In a hip roof, Figure 1, the low pressure zones are everything on that roof other than Zone 3. The high pressure zone is Zone 3, just the corners. On a gable roof, the high pressure zones are 3E and 3R, and the low pressure zones are 1, 2E, 2R, and 2N. When looking at the whole roof and the roof zones, there's 2 options. The first option is the single fastening method, which is you use one fastening method for the entire roof that meets or exceeds both the high and low pressure zones. The other method is the 2 fastening method, where you use one method of fastening for the high pressure zones while using another method of fastening for the low pressure zones. To do this, you need to calculate the size of the high pressure zone, which is in the formula for A. That is covered in another class, but it has to be calculated for you to use the 2 fastening method. Using the Florida 6th edition High Wind Manual, let's look at some tables and how they're going to be used to configure our 6 examples in this wind zone. Table 3, Mechanical Fastening Methods, is found on page 31 of the 6th edition. It lists the various attachment methods and also the mechanical fastening resistant values in foot-pounds over plywood for the low, medium, and high profile tile. It's actually the aerodynamic uplift moments recorded in testing, and you'll need these values to meet or exceed your design uplift moments, which are found on other tables. Before proceeding, I'd like to spend a minute on foam attachment methods. The foam attachment methods may be an alternative to mechanical fastening. These listings are not in the FRSA TRI 6th edition, but rather in the foam manufacturer's product approval. You'll have to look at their patty sizes, their placement, and their uplift resistance, and compare those to your design pressures using that foam manufacturer's product approval. There are now 6 wind uplift tables, 3 for hip roofs, 3 for gable roofs. The hip roofs and the gable roofs are broken down by exposure. So exposure B, hip roof, is in table 2HB. Exposure B, gable roof, is in table 2GB. Likewise, in exposure C, in a hip roof, you have table 2HC, and gable roof, you have table 2GC. And it follows in exposure D, table 2HD and table 2GD. Let's look at the components to determine our fastening. Is it a hip roof, a gable roof, or a combination of hip and gables? What exposure are you in, B, C, or D? Exposure definitions can be found on page 50 of the FRSA TRI guide. What's your roof pitch? There are now 3 distinctive roof pitch groups. We'll go over those in another slide. What wind speed are you in? Always check with your local building department to ensure that your wind speed is their wind speed. What are your low pressure zones and what are your high pressure zones? What's your mean roof height? Anywhere from 0 to 15 feet up to and including 60 foot. Above 60 foot, you'll have to do some engineering. What's your tile profile? Are you a flat tile, low profile, a medium profile, or a high profile? What is your manufacturer's tile ratio? That's based on the size of the tile. And lastly, how are you going to fasten it? Nails, screws, or are you going to use foam? Here are what the table 2s look like. Here's 2 examples. On page 26, you'll find table 2HC, which is for roofs that are hip roofs in exposure C. Table 2GC is the gable roofs in exposure C. We'll now continue and look at 6 examples of roofs at 160 miles per hour. For our examples, we'll make sure they're all exposure C, and we're going to use the same tile ratio, which is a high ratio of 1.10. We're going to do 3 hip roofs at the 3 different slopes on the tables, and those are less than 4.5 and 12, 4.5 and 12 to less than 612, and then 612 to 1212. And we'll also do the same slopes for the 3 gable roofs we're looking at. There are 3 steps to determine fastening. Step 1 is to find your uplift moment table, and you'll need to know if it's a hip or gable roof, and you'll also need the exposure B, C, or D. Second step is to find the design uplift moment, both for the low pressure zone and the high pressure zone. For that, you'll need wind speed, slope, mean roof height, and a new thing called tile ratio, which is an adjustment to the table to the actual dimensions of the tile you are using on your specific project. In essence, it's a correction factor. Step 3 is find your fastening in table 3. You'll need to find a resistance greater than or equal to the design uplift moment you found in step 2. Example 1 will be a hip roof exposure C, less than 4.512 roof slope, a medium roof height of 30 foot. We'll look at all the profiles and a tile ratio of 1.10. Step 1 will be find our table. We see that it's a hip roof, exposure C, so we choose table 2, HC, which stands for table 2, hip exposure C, and we find that on page 26. So we go to step 2, finding our uplift moment, part 1. We go to table 2, HC, 160 miles an hour. we go to our roof slope of less than 4 and 12. We go to the mean roof height of 30 foot, and we find our LPZ and HPZ are the same at 33.2. So now for step 2, part 2, we need to factor in our tile ratio of 1.1. To do that, we found in table 2HC our required uplift moment of 33.2. We bring that over and multiply it times the tile ratio of 1.10, and we increase our uplift moment to 36.5. So we now go to step 3, find our fastening. We take a look at table 3, and we find out in the low profile or flat tiles, those fastening methods can be used in the LPZ and HPZ because they're equal. In the medium profile tile, those fastening methods can be used in the LPZ and the HPZ. And in the high profile tile, you'll find those fastening methods are available for you to use at this wind speed, at this roof slope, and exposure C. Example 2 at 160 miles per hour, hip roof, exposure C, 4.5 on 12 to less than 612 slope with a mean roof height of 30 foot. We're going to look at all profiles with a tile ratio of 1.10. We go to table 2HC and get our uplift moment from that table. We factor in the tile ratio. And then we go over to table 3 and find out for low profile tiles, those faceting methods will work in both the LPZ and the HPZ. For the medium profile tile, those faceting methods will work. And for the high profile tile, all those exceed our designed uplift moments we found from table 2. Example 3, hip roof, exposure C on a steep roof, 612 to 1212. Let's just look at the flat tile. If you look at table 2HC, you'll see the LPZ and the HPZ are different. We still factor in the tile ratio and then look at the LPZ and see that for flat tile, those methods are the only methods available to mechanically fasten the tile in the LPZ. When you look at the HPZ, you'll find out that there's just one method, mechanical fastening, that you can use for flat tile. On battens, you'll have to look at your foam manufacturers and find out the patty placement and patty size to meet or exceed that uplift moment requirement. In example 4, we'll switch to gable roofs, exposure C. We'll start at less than 4.5 on 12 slope with a mean roof height of 30 foot. We have to go to a new table. We'll go to table 2 GC, gable exposure C, and we'll get those uplift moments from the table. We then factor in our tile ratio and then look at the LPZ to table 3, and you'll find out that those methods of fastening can be used in the LPZ. When you look at the HPZ, you'll see that those fastening methods can be used in the HPZ. So we're getting limited at this on a gable roof of this slope at this wind speed of what you can mechanically fasten the tile with. In example 5, we'll stay on gable roofs, but we'll go to a 4.5 on 12 slope to a less than 612 slope, 30-foot mean roof height. We take a look at table 2 GC and get our uplift moments from that table. We factor in the tile ratio, and then we look at the low pressure zones. As you can see on table 3, those fastening methods will work at 160 mile an hour gable roof exposure C, 4.5 12 to less than 612. On the HPZ zones on table 3, you have those fastening methods. So you're constricted a little bit on the high pressure zones and mechanically fastening to just those methods. In our last example, example 6, we'll stay on gable roofs, but we'll go to a steep roof, 612 to 1212, keep our mean roof height at 30 foot. We go to table 2GC and get our uplift moments. We factor in the tile ratio and get our updated uplift moments. We then look at the LPZ, go over to table 3 and see that those fastening methods will work at that roof slope. Go to the HPZ, the corners and the tops of the gables, and we'll find out on table 3 that those methods will work in the HPZ. So those are our 6 examples. For more information, go to www.tileroofing.org. Thank you.